All right, and then, whoops, sorry guys, it just kicked me right out of here. I have to go find it again. What do you guys see right now?
I see the book.
Oh, you do see the book?
Mm-hmm.
I do not. Okay, I do now. Okay. So then finally we have the WTH problems, which are pretty much, you know, things you've, all different types of problems that they're going to call it. So let's get started. If you're going to type in an answer, do it privately so that people don't feel too much pressure. We've had like the pressure problems where people are putting their answer before someone else reads the problem. All right, so we'll chat privately and then I'll check it. So the basics, most models of lines are lines in disguise. Don't let the story distract you. So there's going to be words, but it's basically a linear problem. So go ahead, read example 1 and type in your answer. We'll wait till we get 3 out of 4 answers. You don't need to put units. Is that units, David, you put on there?
Yeah, sorry.
The SAT is awesome. You don't need units. Okay, waiting for a couple more.
I forgot there were letters, A, B, C, and D. Sorry about that.
That's all right, I get it. Oh, Sydney, hi. I didn't know you were here. See, do we have more people here that I don't know about? Sydney, Bryn. Oh, there you are. Okay. Okay, so, all right, Rachel, you did the number thing too. All right, for those that don't know, because not everyone understood how to do this problem, it says an entomologist uses the equation above to model the length of a certain insect in centimeters in terms of the number of months since it hatched. Based on the equation, what is the estimated increase in centimeters of the insect's length each month? Okay, that one sounds horrible. So you can, if you look at the equation up here, I'm going to try to make this so that these aren't horrible. They give you this equation right here, and that's a linear equation. You know that because it's in the form y equals mx plus b. So you have to know what each part, if it's an increase, it's going to be per month, it's going to be your slope. So this is going to stand for your rate, which is the rate of increase, or you can just call it the increase. And so the answer is the number in front, that's your slope of the m. So that's why the answer is just 2.1. So based on the equation, what is the estimated increase in centimeters of the insect's length each month? So each month, it's not like the starting value. The starting value is this number. This is your rate, your increase. So they give you all these words that don't really matter because they give you this formula. But you can just go to the last sentence and figure it out. Okay, a little tricky. Now make sure this week you go through and you do the homework problems that come with this section and use the back of the book to help you figure it out. It has very thorough explanations. All right, let's go down to the next problem. These are all a little different, so it's kind of tricky. All right, go ahead and do example 2. All right, We have 4 answers, so we'll go with it. Okay, good job, everyone. You got it in. Let's see who got it right. Now, we have right here. Do you see that? That's linear. It's not quite in the same format as y equals mx plus b, but you can rearrange it. So it's going to be n equals negative 225d plus 1,562. You have to remember the b is your starting value all the time. Like if you think of a graph and you have a line on a graph, right here is your b. This is your y-intercept, it's your b. So if you plotted it, it would be, of course, this is going down. This is the starting value. So let's see what they're asking. I'm not even going to read the whole thing. It says n equals 1,562 minus 225d, where n is the number of square feet left to paint and d is the number of days he has painted. What is the meaning of 1,562 in the equation? So this one's going to be, Mark has a total of 1,562 square feet to paint. It's a starting amount. So that's what that stands for, the starting amount. Let's see what the other ones say. Mark will paint the entire house in 152 days. Well, it doesn't say anything about that, so we're going to cross that out. We have all different answers here. C, Mark paints at a rate. Now look, rate. See that word rate? Rate would be this one right here. Rate is in front of, if you put it in this form, rate is the one, the m. So the rate would be negative 225, not 1,562. And then here it says Mark paints at a rate of, for, again, the rate of. So you could almost just eliminate these because they're rate, and we want the b value, which would be the starting value. All right, tricky. Make sure you do the homework for this. You got to have more practice than just these. We only have 3 examples for these. Okay, last one of these types. All right, there's a lot of material, as per usual. Okay, the next one. This one has a twist. Don't get complacent. Linear models are designed to twist the normal stuff you know about lines. Stay on your toes and you shall be fine. Ah, right? Okay, so up there we have a graph and you need to find the equation for that graph. Go. Okay, just wait for a couple more of you. Today's just kind of a warm-up if you haven't done this for a while. Okay, let's see what it is. Okay, so remember, what is B? Someone say what B is. Anybody? Man, I hate Zoom. What was
It's the
that?
starting value
Yes,
for the y-intercept.
yes, it's a starting value or the y-intercept. So we can go up here and look and see where it starts, and you can see that it's starting at 9. So we want the y-intercept has to be 9, so it's either this one or this one, right? Because this one has a +3 and this one has a +0. So it has to be this one or this one. And the next thing is we figure out the slope, and the slope is rise 3, run 1. So it's going to be B. So you find the y-intercept to find B. You guys should not miss these on the SAT. Everybody can get these right. They're not bad. So that's the linear models, and there's going to be a lot of linear models on the test. So you will see, hold on a second, clear this out. this. So you're going to see there's homework problems here. You see all these? You kind of have time right now, so do them. And I mean, I'll give you something to do. You know, what can you do in the COVID? You know, sit around and do some SATs. So the answers are really detailed in the back of the book. So go in the back of the book and get the answer, learn how to do them. Basically, just the slope is the rate, the y is the starting value. There's a lot of these. See how many there are? All right, here we go. I took pictures of all of them. So I also put a link to this if you lost your book or you're on vacation and you don't have your book or something like that. You can just, this link is there with all these pages on it, so you can look at that. Okay, now the next group of problems is called the quantity and value models. These are popular too. So many popular problems. Oh, that's okay. Oh, Samantha, you're here too. Okay, good. Pretty good turnout for the middle of summer. Okay, so these are for you Saxonites. So sorry, Judah and Sydney. You missed this, but you probably learned this in another class. These are called quantity and value because there's going to be two equations. One is going to be about the quantity of like coins. If you threw coins on the table, there'd be like 5 nickels and 7 dimes, and the total number of coins would be 12. But the value of the coins would be 5 times the nickels and 10 times the dimes. So we're going to have two equations, one with value and one with quantity. That's why they're called quantity and value models. Okay, Judah. So you have soccer practice 8:30? Shoot. So Judah, round 8 will be taking the SAT, so you can just take that on your own. All right, that works out. All right, so let's see if you know how to do these. Go ahead and try example 1. Just do the problem. Don't look at all the stuff below it. This one's taking a while. Okay, we have one answer. Okay, now they're rolling in. Okay, we're getting a variety of answers here. You could probably arithmetize this one somehow or other, working it, but let's just set it up. I actually didn't solve this one. I looked at my book and I didn't solve it, but the correct answer here is B. So how do we get it? Kind of important how we set this up. So you have 15 coins, that's your quantity. Remember, it's quantity and value problems. There's 15 coins and their worth, that's your value, 270. You Saxon people, this was easy, right? Okay, so you have, what do we have here? We have dimes. So number of dimes plus the number of quarters equals 15. So that's your quantity. The number of dimes, number of quarters is 15. And then they're worth 270. So 10 times the number of dimes plus 25 times the number of quarters equals 270. And then you're just going to solve this simultaneously. I'm pretty sure you could do this by guess and check. Did anyone do it that way? Did anyone work from the answers and go backwards? How about Judah? Did you try it like that? By any chance?
I think so. I don't remember.
No, I mean, that's fine. I mean, I'm not going to actually finish this because we're trying to solve it for how many dimes. So you would multiply this one by -25 because you want to eliminate the quarters. When you're doing these as a time saver, look and make sure you solve for what you're looking for. Like your tendency might be to multiply by 10 because it's easier. I kept setting D to 5. D to 5? Oh, I did the exact same thing when I originally did the problem. So I had to, that's why I didn't do it. I erased it and never went back to it. But let's say you work from an answers. Like we need to learn how to work that because some of you aren't really comfortable with even doing elimination. Like when I'm like multiplying this by -25, you're like, I have no idea what you're doing. Even if you can set up these value and quantity questions, you don't know what to do. So let's just work from an answer. Let's just pick the right answer for the fun of it. So how many dimes? So let's see. So if dimes, so that'd be 70 cents. So it'd be $2, 270 minus 70 cents, because this would be dimes. If we're working from the answer, if there's 7 dimes, it would be 70 cents. And so that would be $2. Then he has 15 coins, so this would be 7 dimes. And so we would divide this by the quarters, divide it by 25, and we would get 8. And look at that, that adds up to 15 coins. So you can totally do this one working with the answers. So you pick the answers, this would be 7 dimes, that'd be 70 cents, that's 7 coins. This is 7 dimes. And we have $2 left, and the quarters are each worth 25, and then there's 8 of them. So 8 quarters and 7 dimes gives you 15 coins. So don't panic if you don't know how to do these. You have the answers looking right at you. So try different scenarios. I mean, if you wanted to start with 6, it wouldn't work because it wouldn't be divisible by 25. I'm trying to give you some different ways to look at these problems. Okay, go ahead and try example 2. Same thing, only we're talking people at tables or something. That's right, David, but I don't know what you're talking about. So, oh, the old problem, you put like worth 5 cents. Okay, gotcha. Okay. If anyone does this by arithmetizing, I want you to explain how you got it. Yeah, a little tricky. Rachel, did you do it this way? Yeah. Okay, so I did, it says that there's 152 people, but there's 18 tables. Okay, this is a little tricky. So if your algebra is not good, these kind of problems, you're gonna have to think of other ways to do the problems. All right, that just, it's just gonna be how it is. You're gonna have to, it's kind of like if you have if you, you know, have some sort of handicap and you have to figure out how to strengthen your handicap, you need to figure out different ways to do the problem. All right, you know, because not everybody's got the same amount of algebra. So we have just the number, I did the 6 and the 10. The number of 6 people tables plus the number of 10 people tables is 18. And then at the 6 people table, sits seats 6, at the 10 people table, seats 10, and that equals 152 people. And then I did elimination. I multiplied everything by -6 on this one. And I eliminated the 6 people table. So the number of 10 people table ends up being 11. So you could draw, if you don't know how to do the algebra here, you can draw tables and just try to figure it out. That's your best bet for that, but don't spend too much time on it. You don't have to remember, if you get half the problems right, you'll get a 500. So it's pretty, it's not like you have to get them all right. Okay, the next one we can all get. Maybe not right away, but we'll see. Sorry, my house just went crazy, like people are all over it. It's a summer kind of jive. Okay, so let's go down into this one. We'll show you some shortcuts, but do your best right now and figure out which one it is. Samantha, are you entering answers? I'm not sure I see anything from you. I'm gonna look up there. Oh yeah, okay, just that you had your camera, okay. Okay, let's see how to do this one. Let's see if you can figure, this one doesn't really take much math. So I think everyone, no matter where your math skills are, you can get these. So Mona needs to order pizza for a party to make sure everyone has enough food. She needs to order at least 12 pizzas. Now, at least 12. We have to figure out what at least 12 means here. So X has to be at least 12. So it has to be greater than 12 or equal to 12, right? You need a greater than 12 pieces to get at least 12. So I'm going to go down, I'm going to cross out everything that's less than 12, the pizzas. X plus Y, the pizzas together. So this one is not, this one's less than 12, so we're going to get rid of that one. This one's less than 12, so we're going to get rid of that one. So you're going to do elimination. So the total number of pizzas have to be more than 12, not less than 12. Okay, and then we're going to go down here. I'm just going to skip all the $14 and everything. It says her budget is no more than $180. So it has to be less than 180, no more than. And she has to order, here we go, and she has to order at least 1 pizza of each type. So they both have to be greater than 1. See that? X is for one kind, Y is for the other. So they have to be greater than 1. they have to be at least 12 pieces together, and the total amount they spend has to be less than $180. So the answer is C. So this one takes really little math skills. It's just knowing what at least is and what at most is. All right, does that make sense to you guys? Do you have any questions on that? Because I want everyone to be able to get this one right on the SAT. Questions? I can see 6 of you. I don't see any questions. I can only see 5 of you actually. Okay, so that kind is all your quantity and value problems. So, anyone else's house is hopping right now? Like mine? They all know when I'm doing something and they all show up. Otherwise, no one even lives here. I don't know what's going on. Okay, so that's your quantity and value problems. You want to have your multiple equations, look at all the problems that you're going to have, blah, 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 blah. Oh, there's not that many. There's only 5. You can do it. 5 problems. Okay, geometry. So geometry with a cute story is more about algebra than it is geometry. Most of these questions involve lengths and widths, so either make equations or you can arithmetize. So go ahead and try example 1. I just read your message, Sydney. Good job. You can do those. Those are good. Yeah, try again, Rachel. Try again, Bryn. Try again, Judah. Wow, I'm going to have to go check my answer. David, try it again. We have everyone put an answer up except for the right answer. I'm going to go look in the back of the book and make sure that I have the right answer. No, I have the right answer. I did it 2 different ways, so. All right, I think we need to go over this one. You can do it 2 different ways. You can either use algebra or you can arithmetize. Let's just do arithmetizing. So it says the length of the carpet is 5 feet shorter than twice the width. So if the width is, I used a bad number probably, I used 5. If the width is 5, it's not going to fit my picture at all, but the length is 5 feet shorter than twice the width. So twice the width would be 10, minus 5 would be 5. Okay, my rectangle is really a square, but it's okay. You could pick higher numbers and it would be better. Okay, do you guys see that so far? The length is 5 feet less than twice the width, and I just randomly picked this for the width. All right, what's the question? Which of the following represents the perimeter? Okay, so let's figure out the perimeter. 5 plus 5 plus 5 plus 5, so the perimeter is 20. The width we made 5. So if I put 5 in this one, 6 times 5 is 30, minus 10 is 20. And we could pick different numbers. just to be more exciting, like what if this one were 10? The width is 10. 2 times 10 is 20. Oh, yeah. Let that be a lesson for you. Read the whole problem. So this is 20, take away 5 is going to be 15. Now the perimeter is 30, 40, 50, right? The perimeter is 50. We let W equals 10, and then we can go back in here and figure out which one it fits. I'm just going to do the one that works. So 6 times W is 60, minus 10 is 50. So I just set it up. That's called arithmetizing. That's like the shortcut on how to do that. I actually did it the first way is I set it up using algebra because I like algebra. So it's W, and this is 2 times the width minus 5. And then I just added these all up, which this is actually easier, right? And you get this. I actually like the algebra way, but that's how you do it. Wow, you know what? Nobody got this one right. This is like a first. Yeah. Okay, and it's an easy one. Yeah, read everything. Sometimes those easy ones get you. Okay, this one's harder. Example 2, go ahead, see if anyone can get this. I arithmetized on this just to let you know how I did it. Hopefully when I show you this problem, it'll help a lot. Okay, we're kind of slow on this one. Do you guys need help? Okay, the answers are not right either. If you put an answer up, it's not right. These are tough ones. I guess these are problem children. Okay, this is totally arithmetized problem. Whenever you're dealing with percents, if you're going to arithmetize, start with 100. Now, I know that looks like a rectangle, but a square is also a rectangle. Okay, Rachel, you got it. Okay, so let's just pretend like it's a rectangle, square is a rectangle. So I'm going to make this side 100 and this side 100. We're arithmetizing, so I'm making that up. I'm making up numbers. It's totally fine. Okay, so if we did this, you could have done 10 and 10, but I like 100s better for some reason. So we know that the area of this whole thing is 10,000. All right, so that's the initial amount. So, so we're going to increase its length by 20%. So increasing the length by 20%, we're going to make it 120 now. So I'll just do a whole other problem here. Okay, so now it's going to be 120 because we're going to increase it by 20%. So that's going to be 120. And we are going to decrease the width by n%. Oh boy, if I can remember how to do this. The modifications decrease the area of the rectangle 16%. Based on the artist changes, what is the value of n? So what did I do? I figured out, I took this and I figured out what 16% of it would be. It would bring it down. It says it decreased the area of the rectangle by 16%. So that took it down to 8,400. I made mine bigger, but it decreased. I should have read that a little bit closer. Okay, so it decreased the area. So I'm just going to take 10,000 and I'm going to take it times 16%. This is probably in the calculator section. Then I subtracted that from 10,000 and it decreased down to here. So what times 120 gives you this? So I took, because length times width gives you area. So I figured out that this side had to be 70, I do believe, 70. So what percentage did it decrease? Well, it went from 100 down to 70, so it decreased 30%. Now, I'm sure there's algebraic ways to do that. I didn't do it algebra. All right, like you could have also thought of it like this, 10 by 10, so the complete area is 100. And then we are going to increase this by 20%, so it's going to be 12. We don't know what this is. If we decrease this by 16%, it's going to be 84. This number has to be 7, and that would be a 30% decrease, going from 10 to 7. All right, some of these are just hard to explain. Anyone have questions on that one? If they're having percents and they're changing it, like if they're upping it 20%, lowering it 30%, start with 100, and then it's easier to go up and down, because if you're increasing 100 by 20%, it's going to just add 20. If you're going to decrease it by a certain amount, it's just going to go down. Okay, enough of that. All right, let's just move on to the next section. These are more geometric models. They look totally different than the ones we did, so use the answers in the back. Okay, I want to make sure I get to this, because you can all get these right. These are another type that are really easy to teach. Ones you can get like some quick points on if you don't know how to do it. So we have linear models and you have exponential models. So linear growth is always in the form y equals mx plus b. Remember this? This is your rate or your slope. This is your starting value. It's going to be a straight line. If it goes like this really fast, increases. If it goes real fast, or if it goes down real fast, this is called exponential growth. And that means you're going to have an exponent, and it's going to be a variable. So it's going to be y equals x to the n or something. You're going to have a variable as an exponent, and that's how it becomes exponential. We're not going to go into all the gory details of that. The formula is right here when you're doing the exponential growth, and that's that open formula that I started talking about. So O is your original amount, T is the time, T is always the time. You kind of have to memorize this. This is something you might want to put somewhere so you can, like in the front of your book or something, so that you can go back to it. The exponent is always going to be the time, and the P is the percent change. Either we're going to growth or decay. So you're going to subtract the percent if it's a growth, or if it's a decay, and you're going to add it if it's a growth. And N is the new amount. Make sure if you have something like 35%, when you put it in this formula, you do 0.35. Don't keep it 35. Make sure you've changed your percent into a decimal. They're going to have your answers probably that for people that don't do that. That's just how they work. All right, so let's go see what kind of problems they give us. So example 1. Go ahead, see if you can get it. It's a lot of words, so you read it. Okay, you guys still working through it? All right, so Grover has 4 job offers, each with different salary options. If he wants to accept a job that yields exponential salary growth, which of the 4 options should he choose? So A is at the end of each year that he works for the company, Grover's salary will increase 1% of his initial salary. All right, that's not nice because it's like 1% of his initial salary. It's not growing faster. Every time they're going back to that initial salary and giving you 1%. You started, at 20,000 and you're still getting the same 1%. Okay, so let's cross that one off. B, at the end of each year that he works for the company, Grover's salary will increase 2% of his initial salary and he'll receive a 5% annual bonus. Well, that sounds great, but it's still going back to the initial salary. It's still going to be a linear. Okay, at C, at the end of each year that he works for the company, Grover's salary will increase 1.2% of his previous year's salary. Now we're talking, instead of going back to the initial amount, every year he's getting 1.2% of the previous year. So that one, it's a little tricky, but that one is the answer. And then D is at the end of the year that he worked for the company, his salary will increase 1,000. That's not exponential, that's just linear. Okay, that was just really a word problem. It didn't really have much math to it. You just have to understand what exponential growth is. However, the next one is a real problem like what we talked about. So I'm just going to slide this down a little bit so you can see the formula. So go ahead and try example 2. Okay. Oh, looks pretty good. I'll just get my answers here. On the wrong page. Okay, so good. You guys did really well on this one. Yay. See, I told you, like, this is one of those kind of problems you can get some, like, 10 extra points just from knowing this little formula. So look at that. We have percent increase. So we have, what is our rate? 2%. So it's 2%, so it's going to be 0.02. And we have to have our initial amount, which is 120. And then it's going to be 1 plus our percentage, 1.02. And the time is hours, so we put the H. And look at that. We look for our answers. It's going to be B, right? B. Yeah. Okay. Isn't that fun? You learned something new. Okay, for some of you. All right, go ahead and do example 3. There's no multiple choice. You have to actually write you have to figure out the answer. Go ahead, you can do it. You can use your calculator. Okay, we got an answer already. Bryn, try putting in your calculator again. Samantha, are you still here?
Yeah,
Okay,
I can turn my camera on. Sorry.
all right. I forget about people when their cameras aren't on. All right, so let's do this together. Sensing some hesitation. Now you guys can all get this one. You can all do this problem, okay? So here's the formula. It's the original amount, 1 plus or minus the percent to the time power. So the initial amount is 800, so you put the 800. 1 plus, it's minus because it says it's decreasing, 12%. So 12% is 0.12. And the time is 3 hours, so to the third power. So you really just want to put this into your calculator and you'll get your answer out. So it's going to be 800 and it's going to be 0.88 to the third power. So make sure you do, your calculator will take care of your order of operation for you. So you can just do 800 times 0.88 to the third power and you should get 545. Now you guys that didn't get this, is there anything that you need more clarity on? You just really just want to put it into your formula. We didn't get a lot of right answers for this one. So just wondering what happened. Anyone want to say anything? You got your wrong answer. Nobody wants to talk about their wrong answer. Okay, so you're just really, these are going to be on the SAT. You're going to get these right now. You just use the formula. Yay, I love these. I love when these kind come up because I know exactly what to do. You just plug them in. Okay, now you're going to get to practice those. Here's some practice problems. There's probably not a lot of them, and of course they're going to have twists and turns and all that kind of stuff, but there's your 6 problems for those. Okay, my favorite kind of problem, because I'm an algebra lover, is these kind of problems where you have to arrange the equations. Okay, see you, Judah. Okay, so you have to arrange it. It says here it's algebra, and they add in a boring story. So it's algebra but worse. Isn't that nice of them? Okay, so go ahead and try example 1. It's a little bit tricky, but you can do it. You guys that are getting your answers in immediately, you just have to be patient. Got all different speeds. All right, hey, this is a really good problem. You guys did great on this one. So the speed of an object is found by dividing the distance by the time. So speed equals distance divided by time, right? And they want to know which of the following equations give distance, that means solve for it, in terms of S and T. When it says in terms of, it means that S and T are going to stay in the answer. So all you have to do is cross multiply, you get distance equals ST. All right, that was an easy one. But you had to like go through the words and everything. Okay, next one, cranking it up a little bit. Now, do you see all the words to this problem? Blah, 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 blah. But at the very last thing, it says, which of the following expresses the square of the velocity of the object in terms of the kinetic energy of the object? So it has a lot of words to say solve for v squared. So go ahead, solve that one for v squared, put the other variables in your answer. Go. These are like free the v squared. They're the best. Okay, so I did it for you. So here's the equation. We want to get the v squared by itself. First thing I did was multiply both sides by 2. You should always get rid of fractions first. So I multiplied this side by 2 and this side by 2, and we got rid of the 1/2. So on the left side, you have 2ek equals mv squared. Then we're going to divide both sides by m. And good, Sydney. And we got this, which is c. See how fun those are? Just free the variable. Okay, they're going to throw some twist in because it's not all going to stay fun in games like that. A lot of these have a lot of words, but when you get down to it, they're going to say solve it in terms of, and then you know it's pretty easy. Now, sometimes they ask you to strip away the algebra and understand the relationship in terms of numbers. And we're going to do arithmetizing. So in this problem, pick numbers and see if you can get it just by picking like different sides. So go ahead, draw 2 plots and try to arithmetize it. Unless you want to do the algebra, which is fine. Okay, we've got a lot of answers here. So 2 rectangular plots. Plot A is 3 times the area of plot B. The length, the widths are the same, right? The same width. So if the widths are the same, so we'll make this one 2 and this one 2. They have to be, this one has to be 3 times as big. So if I make this one 3, it'll make this one 6. And if I make this one 1, it'll make this one 2. So this one is 1/3. So if the widths are the same, this area has to be 3 times as big. So I made this 1 and 3. Do you guys see what I did? I'm not explaining it very well, but so this one's going to be 1/3, 1/3. I did it algebra. If you do algebra, I made this one 3a and this one a. And we know that area equals length times width. So if the widths are the same, then we know this is length, and this one has to get the 3a, it's going to have to be 3 length. So Yeah, so it's 1/3. This one's 1/3. It's actually not that hard. You just have to think about it a little bit. Okay, and the last one of this before we get to the what the heck problems. This is the last one before we do that. So go ahead and try this container problem. Hmm. I can't tell which answer was from the old one or the new one now. Hmm. You guys all stuck or something? I'm only seeing answers from Sydney and Bryn, I think. David, you got an answer there? Rachel? Okay, so you know the radius, so I don't want to spend too much time on this, is 4 times as big. The volumes are the same. Volume A, volume B. So volume, you have to know the volume of a cylinder is, it's the area of the base, which is a circle, right? Pi r squared times the height. You can look this up in your SAT book, but you don't really have time to go looking at formulas. So you should have the cylinder formula memorized. So volume equals pi r squared h. So for the first one, we know the volumes are the same. So the second one is pi, the radius is 4r squared, so I'm going to put that in there. So B is going to be pi 16r squared h. And if we compare them to, this one is, it's 1 to 16, not 1 to 4. So the answer is going to be D. If you put them over top of them, it says, what is the ratio of container A, which is pi r squared h, to container B, which is pi 16, whoops, this shouldn't be, yeah, r squared h. All this crosses out, look at this, and you just get 1 over 16, the volume. All right, there you go. Okay, let's just see the what the heck problems. I might not do those because they are really random. So I don't know why they call them what the heck problems, but They're just a bunch of random problems. So I'm gonna just let you hash those out so that we don't use all our time today. Plus it gets really boring after a while. They're not really too much new. So look at the answers in the back of the book. He has really good help for those. So you want to be a self-learner and look in the back of the book and figure it all out. So we're not really going to take a break. We're just going to move right on. So we're going to be doing test 5, section 3. I laid out pretty much the rest of the, until you take the SAT. Samantha, when are you taking it?
I have no idea.
You, David. Okay, so you didn't sign up yet.
I think my mom might have.
It's like people aren't able to get in the August, so you'll probably do September.
Yeah, probably.
So you just want to be, you know, like when you guys make sure you pace yourselves so that you're like, if you're not taking it until September, that you save some SATs for them. You can go back, you'll see on this, on the sheet. Let me just do something here real quick. Before we get going, you guys can start finding that. Let's see if I have the, hold on a second. Let's see what I got here. So if you look on the accountability sheet thing, maybe I can't find it here. Things are on top of it. Okay, here it is. If you look at this, I put stuff, I mean, do as much as you can. It's summer and there's like, either you have extra time or you're like, don't feel like ever doing school again because it's summer. But here's kind of like the plan that I put out for you guys to do the work. So we're gonna do this in class. Here's the videos if you wanna watch to see how to do them. So you're gonna have to get back in the groove of things. And then I have week 6 is what we're gonna do next week. Just a lot of other junk. And then the final prep. This is where you can pace yourself, like preview, review all these, and then I have you doing test 10 and test 9 again. You already did them, but they're the ones that are most like the real SATs. That's what the book says. So you want to do test 9, 10, and 9 again. Test number 1, 2, and 3, they say those aren't like the real SATs. Even though it says the real SATs, they say they're not. So you want to redo test 9 and 10. So that's the sheet, you know, just do what you can on there. Whatever you can do to prep is going to help you. So you guys ready? You got 5 ready? Let me set my timer. I know it's a little torturesome. I feel really cruel when I teach this class. So I'm going to set my timer for 25 minutes and let's see how you do. You can turn your cameras off if you want. I don't care. You ready? Get set to go.
Wait, we're doing test 5?
Yes, do you have it?
No, I don't have it.
Okay, just look for it and start it. Look on, just look it up on the computer. All right, guys, time is up. Are you there? Are we back? How did it go?
I literally found it like 10 minutes ago. So I only have like the first 5 done.
Okay. You just found it. Oh, man. Yeah.
I'll finish it though.
Okay, yeah, finish it. I'm going to flash up the answers now. So let's go through the answers and see how you did. I actually kind of like that one. There were some really tricky ones in there, though. So maybe we can look at some of the really tricky ones. So here we go. I don't have to belabor you guys on to the top of the hour, but let me see if I can find the answers now. Okay. I'm being really slow about this. Okay. So come on. All right, there it is. Hold on, there we go. All right, so here's the answers. So you ready to check them? So are we down to 4 people? Participants we have, yes, we lost some people. Okay, so here's the answers. 1 is D. I'll read them out, but you can see them up there too. 1 is D, 2A, 3B, 4C, 5D, 6A, 7C, 8A, 9A, 10B, 11C, 12D, 13B, 14C, 15D, 16 is 4, 17 is 6/5, or 1.2, 18 is 21/4, or 5.25, and 19 is 2, 20 is 97. So if you feel comfortable, you can privately text me how many you got right. Oops, I lost my text thing though. Chat. Okay, 1 person felt comfortable. Okay. All right, so there's probably some really baffling ones on there. So does anyone want to see any of the ones that are like totally baffled on? They just sat there and stared at it. I did them all. I kind of like this test. Go ahead, no one else can see it if you want to type in any. Number 9. Okay, so 9, Bryn, calling you out on this one. You can do this one. Y equals x squared. Wait till you see it. You're going to be like, oh, I could have done this. Plus 6, because this is pure algebra. 2 times x plus 3. How do you do that one? Well, you can see y equals x squared. So I'm going to substitute x squared into the second one where the y is. So you get 2x squared plus 6 equals 2x plus 6. The 6's cancel out. Set it equal to 0 because it's quadratic. 2x squared minus 2x equals 0. Take out a 2x and you get x minus 1 equals 0. And x equals 0 and x equals 1, but 0 is not a choice, so it's going to be x equals 1. That's how that one works. You can also, you could have like put this like this, substitute, or right here. You could have substituted and then put the numbers in for x and arithmetized. Oh no, what's the answer of x times? Oh, I didn't even get this right, honestly, because the answer should be 0. What's the value of x, y? Oh, so then you have to go back and get x. I didn't even finish this. I got it right, but I didn't do it right. So you go back up, you take 1 back up here, and you get y equals 1. And then the value of x, y would be 1 times 1, which would be 1. So I got the right answer, but I didn't do it the whole way right. How about any other ones? I know you guys are probably exhausted. How about one more? Anybody? Sydney, do you have any? I thought this one was tricky. It's number 12. Did you guys get this one right? 9 to the 3/4. This was not a calculator problem, so you can't just put them in your calculator. How'd you guys feel about that one? Feelings? Not great. I know, like, what do you do with that? Like, look at that. First thing I did was I know that this bottom number is the, oh, you got it right? Rachel, good. Okay, the bottom number is your on the seat. Remember, the bottom goes on the seat and the other one goes out here. And that wasn't getting me anything. So I had to really play with this one. It was like really playful. I took the 9 and I made it 3 squared. I just played with it because I didn't know what to do. This did not get me any of the answers. I tried all different things. And then I figured this ended up being 3 to the 2 goes into 4 2 times, the 3 halves. And so that was the, that ends up being the square root of 3 cubed, which is the square root of 3 times the square root of 3 times the square root of 3, which is 3 root 3. Not fun, not easy. You have to really think on that one. So the rest of them, some of you got 15 out of 20. You feel good about those 5 that you missed, you 15 out of 20ers? You're not curious on how many of those work? Okay, well, I'll let you go with that then. Make sure you go and there's the answers on the spreadsheet here. Well, let me get to that. On the spreadsheet, the answers are on here. So you want to go back to this videos for this and you click on there and it will give you somebody's videos that show you how to do every problem that you might have missed. So go back, try to really learn from your mistakes, and you got a lot of work cut out for you. So we're going to meet next week. If you can't make it, I'll be recording it, but try to come because you'll get more out of it if you come. I know it's a lot of material too. All right, so that's it, guys. And we'll see you next week, same time, same SAT place. Alrighty?
Thank you.
You're welcome. We'll see you guys. Bye-bye.